take these notes and please enjoy. Okay, I did it already. Okay, all right. Now finally I can teach you math. So sorry for the long delay, but now we're ready. Let me remind you, yesterday what we did is we graphed a bunch of, guys, let me talk for a second, please. So we graphed a bunch of functions like this, actually 2 or 3, but we had to plug in all these points. Oh, shoot. We had to plug in all these points into there, then get a number for this, plug this point into there, get a number for y, plug the next one, and so on. And so it became really, really tedious. And so today's a big, exciting day because I'll show you how people normally graph things, like in higher maths. They don't want to spend the time plugging in six numbers and then finding them on the graph and all that. They just do this nice little shortcut. But to know that shortcut, you have to understand what's going on. So let me get into that. Recall that this is basically what I just said. Graph each of the following graphs alongside x squared and identify the transformation of the parent function. Rexy, were you here yesterday? Yeah. Okay, then you already have these though. Okay, all right, so watch this. These are the shortcuts that you're gonna look for to be able to graph these without a little table. If you like the table, okay, but I think most people get annoyed at the table. So what you look for is anything, so okay, first of all, you know what this parabola looks like. That's the most basic parabola. This is called the parent function. Because that's the most basic parabola. Nothing's being done to it. It's not being multiplied by 2. You're not adding 5. You're not taking negative that. It's just the most basic one. That's what they call the parent function. And from that, you can get any other parabola based on what's being done to it. So for example, this parabola, negative x squared. You guys remember what a negative will do to the x squared? Yeah, it'll make it open down. That's called, first of all, that's called a reflection because it'll reflect over the x-axis. So it's called reflection over x-axis. That's not a lot of room, sorry. You could just say reflection, I guess, but technically you should say reflection over the x-axis because you can reflect it the other way too. And again, that's because of this negative right here. That's what I'm looking for. And so that negative right there tells me everything I need to know because I already know what x squared looks like. So negative x squared will look the same, but upside down. Oh, okay, I get it. Okay. So our graph will look like, let me make it a good color so you can tell whose is whose. Our graph will look like same thing, vertex at 0, 0, that's 2, 6. And then same thing as this. So notice the original parent function goes up 1 over 1, up 1 over 1. So same thing down here, but now we'll go down 1 over 1, down 1 over 1, still too big. And then our graph will look basically something like this. Like you don't need to be super accurate. You just need to know the basic shape of it. And that's what people do in higher maths. They just like look for what's weird about it. Like in this case, negative. So then they know how to adjust their graph accordingly. Hello, hello. I think you were gone yesterday, so take these. Okay, so same thing here, except now we're doing a different transformation to it. But okay, we know what the parent function looks like, so we can adjust this one accordingly. You guys remember, well, first of all, what's being done to the x squared here? Like what's different from x squared in this one? Okay, yeah. That's the thing I'm talking about. Like what's being done to it, and in this case, it's being multiplied by 2. Do you guys remember what that does? The number in front. Yeah, it affects the width of it. So in this case, since it's a 2, it's getting to bigger numbers twice as fast. It's actually going to get narrower, like skinnier, like more intense the curve. And it's called a vertical stretch because if you took this and stretched it vertically, it would get a little bit narrower. So this is called a vertical stretch. And technically it's called a vertical stretch by a factor of 2. I'm just showing you the big proper names for all of these. I don't really mind if on your own worksheet, you just write reflection or stretch or vertical stretch. But that's what the name of it is. Okay, cool. And then, so what that does is, like I just said, it's gonna get to the bigger numbers twice as fast. In other words, this will look the same as the original graph. You're not moving the vertex at all. It's still at 0, 0. But now, instead of going up 1 over 1, it'll get twice as big in that same time. So what I'm saying, you'll go up 2 over 1 because of this 2 right here. And then up 2 over 1, again, because of that 2. And so your parabola will look something like this, narrower and more intense than the green one, or than the red one that's already in there. Okay, so hopefully that makes sense, and hopefully you see the benefit of this. This is like, instead of doing tables, you can do this. Also, one quick question, if this was a 3, or I don't know, yeah, let's say a 3, then what would I have done instead of going up 2 over 1? Yeah. Yeah, up 3 over 1. Yeah, and then there's one that's like 1/4 on your own worksheet. I'll talk about what you can do instead of going up 1/4 over 1. We'll talk about that later. Okay. Then we learned about one more type of transformation. Here we have x squared, but minus 5. So this is the thing that's being done to it. You guys remember what that minus 5 does? This is the thing from yesterday. But yesterday was a short day. I would be impressed if you remembered. You're a beast. Yeah, remember it moves the whole graph down 5. And we talked about what that's called. That's called a translation. Translation down 5 units. Or a vertical translation by 5 units down, or something like that, but I think that's the most direct way to say it, the most efficient. Okay, cool. So like we just said, we already know what the original graph looks like. Our green one will just be the same graph, but 5 units down because of this minus 5. So I'm just gonna take this vertex, move it down 5. Then the original graph just goes up 1 over 1, up 1 over 1. So that's what I'll do as well. We're not messing with the width at all. Cool. Okay, so our graph will look something like this. Again, it doesn't have to be super perfect, but you get the general idea by doing that type of thing. So as long as you have like 2, 3 accurate points, that's all you need. Here's what I don't want. Don't do this on your paper. I wouldn't want you to be like, oh, it moves down 5, so it looks something like this. That would be bad, because that's not accurate at all. Okay, and then last one. This one is crazy because why is this one crazy? What'd you say? Well, yeah, okay, that's one thing. It's going to be going up 1, so yeah, maybe I write that already. Translation up 5 units. And it's going to say up 5, even though that's lazy. I don't have a lot of room. But yeah, what's the other thing? Yeah, there's 2 things with it. Not only are you adding 5, but also you're making it negative. So you have to reflect it. Good job. Sorry, I thought I had printed this down here, but I guess I didn't. So squeeze it in the middle here. This is a reflection over x axis. Okay, cool. So basically what that means in terms of like how people think, they don't think, oh, I'm going to translate this and then reflect it. They just think, okay, it'll open down and it'll be 5 units up. So that's what's up. This. Oh, sorry.
Sorry, I couldn't read that.
So what I think when I see this is I think, okay, it's going to open up and it's going to start open downward and start 5 units up. So that's what I do. I put my vertex up here at 5, and then I know it opens down, but with the same width. So still down 1 over 1, down 1 over 1. If this was like a -3 down here, then I'd go down 3 over 1. But no, -1. So that's all you need to do. And then here's the idea. Okay, I can't get a read. You guys understanding this a little bit, more or less? It is a more advanced way, but a less annoying way, I think, than using little tables. But if you like tables, you can always use tables. I'm just saying this is nicer. Yeah, okay, this next part is what you're supposed to be turning in. So if you have tuned out, tune back in, listen. This is what you'll turn in today for a grade this week. So turn in the back page, you can rip it out, or you can turn in your whole packet, but I'd rather you rip it out. And then it's just a bunch of graphs and then one word problem. I got asked to do which one? 4? Yeah, okay, that's a good one to do. Yeah, okay, let's do 4, and then I'll leave you guys alone. I can help you guys. Okay, so 4. There's actually 3 things going on. So are there 3 little lines? Yeah, okay, I did good. Okay, so watch this. The 3 things going on, actually, you tell me what are the 3 things going on. What's happening for this x squared? What's one thing? Yeah.
Vertical stretch by 0.5.
You're a beast. Okay. Ooh, and also, I should say something. So this is a vertical stretch, you're saying, because we're multiplying it. But really, we learned that if it's smaller than 1, it'll get wider. That's called a vertical compression, because if you were to like compress this, it would get wider. I didn't say that, but yeah, if it's smaller than 1, that's technically a vertical compression. If you mess that up, I don't know that I care so much, but that's the formal word for it is vertical compression by a factor of 0.5, but I don't have room to write that. Okay, so that'll get wider because it's a 1/2, and you'll see why that is. Okay, what's another thing that's being done to it? Maybe I do it in a different color. Is that a hint? Yeah, please. Yeah, it'll reflect because of what? What told you that?
The negative.
Okay, good job. Aurora, be back. Like, I don't want you to miss all this learning. Okay, so the negative means reflect. Over x axis. Cool, okay, and then there's one more thing being done to it. Yeah, Andy.
The translation by 2 is.
You guys are beasts. Yeah, really good. So this plus 2 tells you that you're moving it up by 2. That's called a translation by 2 units. Okay, all right, okay. And then hopefully you know what all these mean. The green means it's going to get wider. Red means it's going to open down. Black means that you're going to move the whole graph up 2. So I would do this like start at the vertex, which I know is going to be 2 units up. Then I know it's going to open downward. And then, okay, here's the thing that I was going to talk about. We know that the parent function, the most basic graph goes up 1 over 1. This should only do half of that. So you should go down 1 because it's negative and over half. Or even better, even more intuitively, maybe, is go down 1 and over 2 instead of 1. Because that way it's like twice as wide. So it's up to you whether you want to do this half, like down half over 1, or over 2 and down 1. I'll do it both ways. There you go. And so your parabola will look something like this. Okay. All right. That's what I've got for you. I am absolutely sure that most of you guys this is like higher level stuff. So I'm sure that most of you guys are like, I don't know how to start this, but try it. I'll walk around. I'll help you guys. But yeah, I won't be surprised if you're like, I don't get this at all. So call me over if you need help. Talk to your friends, talk to your neighbors. And I think that's all I've got. Turn this in at the end of the period, by the way.